All right, so this video is going to be on lathe lesson 7. It's going to be on the tutorial. So let's get started. First thing that you're going to do here is you are going to go and select a machine. So let's go to machine, go to a lathe, and I'm going to select the Haas ST4X. If you don't have that, of course you can always select default. Again, I don't grade on what post processor. As long as you haven't chosen a post processor that cannot do the functions that are required in the tutorial. So if we have live tooling and you have a post processor that isn't able to do live tooling and we can't run it in simulation, then that tells me you haven't checked your work, and then I would take points off. But aside from that, default will always work for everything. But if you have the Haas ST4X, that is preferable since they're the machines that we have in the shop. Once you've got that selected, the next thing you're going to do is you're going to go to your planes and you're going to select your DZ plane and work off of that. So you're going to hit top to know that it is correctly selected down here in the lower left-hand corner of the geometry, or the geometry box here, or our window. Where our geometries, our construction, this is where you'll find the DZ. All right, so let's move on. Okay, so we're going to start drawing this thing. There's quite a bit going on here, so I'm not going to follow the way the book tells you. The way the book tells you is fine. You can do it that way. It's another way of doing it. I think my way is a little bit quicker. I tend to just use a line, multi-line, and I just start from the beginning and work my way around the part. So to start off, of course, I'm going to start at 0, 0, and the next point, I usually forego the chamfers when I do this method. Put those on later with your chamfer command up here. So it looks like I'm going to 0.875, 0. Next line is going to be 0.875, negative 0.5. It looks like the next line then, okay, so we have a little groove and it's 100 thousandths deep. Now it's showing a depth, so what that means is, since we're currently at 875 and that's where it's measuring the groove from, we actually have to double that because it's on both sides to get the diameter. So we need to subtract 200 thousandths from 875, which gives us 0.675, negative 0.5. Then, of course, we're going to go 0.675, negative, and we're going to add the 200 to the 500, and we're going to get 0.7. Enter. It looks like we are then going back up to that 875 dimension. So we're going to 0.875, negative 0.7, and 0.875, negative, and then we have to see how far back we are actually going here. So to that first, okay, so we have a radius there and we have an angle. So right here is where I'm going to stop. I'm actually just going to draw a line straight, and that will intersect the angle that we have coming down. So what I'm going to do is I'm going to start at the top of that angle where it comes down. So it looks like that is a diameter of 1.125, negative, looks like 3 inches minus 1.5 inches. So that's going to be 1.5 inches. So we'll go negative 1.5, enter. All right, so there's the top of our angle. Now we just need to create that angle. So it looks like here it's 40 degrees, but it's showing that that's 40 degrees from 90, or 90 on our 0 is 3 o'clock, 90 on our clock, the way we always measure angles. So 90 plus, it ends up being 130 degrees from 3 o'clock. What we really need to know is, we need to know what the angle is down this way. So basically we want to know what negative angle we have. Well, opposite interiors tell us that it's going to be 90 minus 40, so we get 50. So we're going to have a negative 50 degree angle. Negative 50 point, and there it locks our angle in. And then what I'll do is I'll just trim this. So I'll have to just divide, trim, trim, and there's my angle. So I'm going to pick back up there with my multi-line and continue on. Okay, so, oh, well, actually, check that. Looks like we have to do a radius. So we're going to put a radius in. It looks like the radius that we have being called out here is 0.3. So let's pick our circle. And let's see where that's located at. So it appears that that's located at, looks like it's measuring 0.8 from center line to the center of that radius, or the center of that circle. So we have to double that. So the center of that's going to be at 1.66, comma, negative, and then we need to subtract 1 1/4 from 3, which is just going to give us 1.75. So it's going to be a negative 1.75. Enter. And that helps us create our radius. All right, so now all I need to do is type in my radius, which of course is 0.3. So 0.3, enter, and there we go. So now we can continue on. So since it didn't give us a dimension for that distance there, I wasn't really able to run that at the moment. But now we'll come back and we'll trim all this. All right, so what I'm going to do now is, I'm already on multi-line. So what I'm going to do is start at the back of the part. So I'm going to go to 1.45, comma, negative 3.0. Oops, I messed something up in there. 1.45, comma, negative 3.0. And we're going to take this, looks like, to 1.45, comma, negative 2.875. And it looks like we have 100 thousandths depth, so we're going to take that to 1.25, comma, negative 1.875. Oops, looks like I messed up again. Slight mistake, so let's delete that. Go back into a multi-line, start there. And what do we say, 1.25, comma, negative 1. Check that. That's where I messed up, 2.875. I accidentally put a 1.875 in there. And you can see here, I didn't delete my 1. There we go. So that gives us the correct dimension. All right, so 1.25, comma, negative. It looks like our width is 0.2, so it's going to be negative 2. Instead of 875, we have to subtract another 2 from that, so it's going to be 675. Enter. And then we're back up to 1.45, comma, negative 2.675 again. And it looks like we are then 1.45, comma, negative, and we got to subtract a ½ inch, so it's negative 2.5. And that's the start of our angle. Okay, so now that we've started our angle, it looks like it's 18 degrees, and that is measured from horizontal. So now we could just go a negative 18 degrees, because again, opposite interior angles, it would be a negative 18. So I'm just going to put a negative 18 point in here. Oops, helps you don't put 2 points. And there we lock in at that angle. So I'm just going to click it extra long. And what I could do is I could just delete this and just create a new one. And now I can just trim everything. So I'm just going to trim that. Oops. Sometimes this trim can be a bit fussy, to say the least. There we go. And there we go. So that is our profile. Just need to add some radii and some chamfers. So let's go and do that. 0.0625 is our chamfer on the front. Check that. I think that's the only chamfer we have. And then we have some 50 thousandths radii, which is right here. And right here, I believe. Yes. Hit check. And that takes care of our profile. So there is our profile all finished. And lastly, we just have to put our counter bore on here. It looks like that's a 1/2 inch counter bore, and it appears to be an 1/8 inch deep. Okay, so let's just grab our line. And for this, I'm just going to do multi-line. I'm just going to do a 0, negative 0.125. I'm going to start in here. I'm just going to go to 0.5, negative 0.125. And I'm just going to overlap that. And I'm just going to divide and delete it. There we go. All right. So there is our complete finish with the counter bore. So now that we have that, we are ready to rough this thing. First, of course, we need to set up our stock. So I'm going to go to my stock. Of course, I'm going to select the correct plane. And next, I'm going to go to my stock setup. And it looks like we can get away with 1.5. Our length of our part is 3.0. And if I use my margins, I'm going to make 2 inches to hold on to. And oops, check that. That's supposed to be 0.01 for the face. The left margin is supposed to be 2.0. And hit check. Check. Okay. So there's our stock. We're all ready to go. Actually, let me make a quick change to that just to show something. Let's say we only have 1.75 stock and hit check. All right, so let's go to our turning. Let's face this thing. I'm going to go ahead and just pick our normal facing. Maximum spindle speed is 3,000. 900 is our surface footage per minute. And I usually face it about 0.005. I can go faster, but I'm just going to start with that. Everything in here looks pretty good. I don't need to worry about compensation because, of course, this is only cutting in the X direction. So I'm just going to hit check, and there is our face. Okay, next, we need to rough this thing out. So let's, now your book for this, it has you use your quick rough. So if you click over here, right click, and you go to Lathe toolpaths, you can go down to quick and go to quick rough. And I'm going to select this chamfer and the back there. Select my tool. Surface footage, of course it's 900. Feed rate looks good. So you notice you don't have as many settings capabilities in this. And that's one of the downsides of this. Also, sometimes this stock recognition is a little goofy with you as well. So your stock is outer boundary. Lead in, you can see your lead in doesn't quite have as much. Or lead out, we can extend the contour like we usually do. So it's rough step, our D value, if we were doing a can cycle, will be 100,000. So it's going to take 100,000 to pass. But essentially, you don't have a lot of settings. So this is okay, provided that you can use this, get the stock recognition to work. I really don't care if you use the quick rough or if you use the regular rough or if you use the can cycle rough. I personally prefer the can cycle rough. I try to use that as much as possible, which I'll demonstrate that here. Actually, we'll be demonstrating that in a future video. That'll be up in, I think, lesson 8. I think we'll talk about the can cycle rough. So anyway, I'm just going to go with this one for now, since it shows you to use this one in your book. So I'm just going to put control in. I always use control in the lathe because I don't want it to compensate for me for whatever tool I select in here. I would rather just put that in the lathe because the problem is sometimes you change out inserts in the lathe and you use a tool with a different radius. Then you have to figure out what the difference is between what you programmed in here and what you're using out there. So if you just pick control, you can put in whatever nose radius you're using at the machine. And then it'll work perfectly fine. So I'm just going to pick control, check. Now it won't simulate as good when you just pick control. So it won't complete your radii correctly. It'll simulate them the same way it would if you didn't put anything in the machine. So just be aware of that. All right, so there is our rough. So it roughs everything. It does not plunge because we don't have it set to plunge. So it looks pretty good right there. Let's go ahead and do a finish. So we'll use a quick finish like it shows in the book. So, oops, not mill, lathe. So we'll do a quick, and we'll do a finish. Doesn't ask you for a profile because it knows since you did. Well, it actually may if you're using 2020 or 2019, but in 2021, which is what I am currently using, it does not ask you for a path because if you do a finish right after a rough, it assumes the same one, which is kind of a nice update. For this, we're going to use our right-handed 35-degree diamond. This is a letter V in terms of the insert that is used. Okay, so spindle speed, we're going to say it's about 900. Surface feet per minute. Feed rate is about 5. Let's make that about 8. We can crank that up a little bit. Your feed rate is just going to depend on what radius you have on the tip. I mean, this has a 15,000, so we probably could reduce that, but generally I would use probably a 30-second radius on this tool. But again, that's going to be determined by what I put in my machine because I'm selecting control. Okay. So, finish, right here we have finish step over. We don't really need that because it doesn't matter. We're only doing one finish and there's only 10 thousandths left on our lead in. We do want to change this, extend this contour. We're going to make this 0.15 and hit check. And we're going to also... Actually, everything looks pretty good there. Yes, I'm going to hit check. Yep. Okay, that looks good. The one thing I was thinking is I want to double check how much I left on it. Sometimes I accidentally put 0.01 in here. I want 0.05. I only like to leave 5 on in the Z just because it's plunging into a face and there's not as much clearance, so more of the tool engages the face, and you can get a lot of chatter if you have too much left on there. So I just wanted to fix that. And that looks pretty good. All right, so that looks good. The last thing we need to do in terms of turning is we need to cut this. So what we're going to do to cut this is we're just going to use a finish pass and we're just going to machine this out. The first thing you can do is you want to check to see how deep this is. So I'm just going to go and dimension to the bottom and pull it off to the side. So it's only 62 thousandths. So what I'm going to do is I'm just going to do a finish pass, but I'm going to take 2 of them. So let's go to turning and let's go to a finish. And I'm just going to do a single here. All right, check. And I'm going to use that tool. Of course, my max spindle speed is 3,000. This is 900. And 5,000 is fine for this. Finish step over, we're going to make this 0.3. 0.03. And actually, I'm going to make it 0.035. And we're going to do 2 finish passes. And we're not going to leave anything. Okay, so I'm also going to turn on my wear, or my control for wear. And in my lead-in, I am going to extend the beginning. What I want is I want that arc to extend up a little bit past. So for example, when I get back to my geometry screen, I'll show you what I mean. I want that arc to extend a little bit past the X diameter. So I'm just going to extend it maybe 0.05. I'm not sure what your book has you extending it, but 0.05 should be plenty. It's more than the tool nose radius. That's what's really important. And I'm going to do the same thing with the end of the contour too, 0.05. Oops, 0.05. And I might be going a little more than I need to, but that's fine. And plunge parameters, I need to turn those on. So I am going to turn on allow to plunge in both directions and hit, because I am going to be coming in at both directions. It's not going to be going in just one direction since it's actually doing that arc it's going to be moving in the Z and also in the X. So I want to make sure I have both on. So I'm going to hit check. And that looks good. All right, and you can see right there, I am cutting my profile. Now, if I was concerned about this finish, or if I was getting any kind of, if this wasn't coming out quite to spec, and by the way, this is just showing you, this is because the tool nose compensation is on, that's why these lines don't line up with the gray. But if this wasn't coming out quite right or to spec, what I might do is I might do 2 finish passes and leave maybe 5-10 thou on, and then do another separate finish pass and take that little bit off. Then I would be getting a very low cut pressure as I was doing that finish pass, and that would help get rid of any deflection or anything like that. Honestly, I think this would be fine. So that's how I'm going to choose to do it for this this particular part. All right, so let's go ahead and simulate that, but first let's save it so if anything happens, we don't lose everything. All right. Play. All right, I'd say it looks pretty good. Now again, remember, because I'm picking control for my compensation, that's why it's doing this. So if we go back in, we can get rid of that, but you got to change it back. So let's go back to, let's go to this one here, the one that actually is. And if I just pick computer and I run it, see now it's very accurate. So it's right on that line now. So that's the reason why it's showing it like that. So if you want to make sure that it's right, what you can do is just go ahead and run that under computer, but then make sure you change it back before you actually go to run it on the actual machine. So I'm going to put that back on control and hit check. For these exercises, you can leave it on computer. I'm okay with that. I'm just telling you that if you're going to run this on the machine, you don't really want to leave it on, or you don't want to leave it on computer. You want to have it on control so you can control that radius, that tool nose radius, at your machine. So let's hit regenerate. Okay, so everything looked good there. Okay, so next thing we have to do is we have to groove these. Looks like we have 2 grooves in here, so we could take those out, or we could do this first. It really doesn't matter. We could drill and tap this. We could also do this first. Either one is fine to go ahead and do first. I'm gonna actually drill and tap it first. And I'm not going to spot drill this. I'm just going to assume that I'm using a split point drill or a carbide drill of some sort that doesn't require the need to spot drill. So I'm going to go ahead and hit drill. It looks like we are tapping at 1/4 20, so we're going to need to go to our tool library most likely. And we're going to need to go to lathe drills. And let's scroll down. There it is, number 7. That is our tap drill size. Looks like if we go inches per revolution, we'll feed this at 0.002. 2 thou per revolution. Actually, probably 0.003. We'd probably feed it a little faster than that, but that should be fine. Let's go to a depth. In this case, it's calling out, looks like we're at about a depth of a 1/2 inch there. It's not specifically saying that, but that's essentially what I'm seeing there. So we're going to take this, a 1/2 inch deep. So I'm going to say -0.5, and we're going to go absolute. Not worried about anything here. Clearance is fine. The retract is fine. We can make those all absolute, in fact. And let's put our drill tip comp on. And Actually, you know what? I'm going to add it up here with the calculator. So if my tool diameter is 201, we're not going to have any flat on the tip. This is basically what calculates our tip. So we need to add an extra 60 thousandths to that. So I'm just going to hit add to depth and hit check. And that should take our drill, or right where the margin starts on our drill, right to depth of a 1/2 inch. So I'm going to look at this. Nope, nothing in there. Hit check. And there is our drill. Next thing I'm going to do is I'm going to go ahead and tap this. So we're just going to go into drill again. And of course we are going to select a tap. So I'm going to go to tool library. And I don't think our taps are in here. I think they're elsewhere. Yeah, they are. So we got to go find some taps. And I think that's in Lathe. Where is it? Taps. L taps. There it is. Okay. Search for a 1/4-20. There it is. 1/4-20 right-handed tap. Okay, so we're going to go inches per rev, 50 thou. It's going to be, that is locked in. It has to be the pitch of the tap, right? Or more accurately, I should say the lead of the tap. Because if the lead may be different if it's a multi-lead tap. This case, it's a single lead, so it's pitch and lead are the same exact thing. Spindle speed, 1,000. That's okay for a 1/4 inch tap. Now, assuming we're in steel, we may want to slow that down a little bit, so I'm just going to make it 500. And the depth. So for this depth, we are going to take that to exactly, we're going to take this to 0.5, and we're going to assume that this is a bottoming tap. And that may not quite get us all the way to where we need to be. It might not get us to a 1/2 inch thread depth, but if anything, it will be shallow, and we have less likely a chance of breaking the tap because we're only going a 1/2 inch. In fact, I might even just make that shallower if I were running this part because I want to make sure I'm not going to break that tap. This isn't a really good drawing. Basically, it's showing that you have to make the tap the same depth as the hole. Usually you can drill a little deeper. If that is the case, you need a bottoming tap, and you really have to be careful. So I would probably start with a smaller number and then step it in gradually till I was sure that the tap wasn't going to break at that depth. But I'm just going to put 0.5 in because we're just simulating here. So we don't need any tip comp for this because we're going in exactly to 0.5 from the bottom of the tap because it is a bottoming tap, we're going to assume. Okay, so there's our tap. And now we can bore this thing. All right, so let's go ahead and assume that we're boring this, but one of the things that you'll notice is this here comes the whole way down to the center. What I'm going to do is I'm going to shorten this up a little bit. So I'm just going to trim it, and I'm just drawing a random line inside of that hole there. Because I don't need to go the whole way down. This is all drilled out, and I don't need to go the whole way down. It's going to make it difficult because an end mill or a boring bar is going to try to start down here, so I'm going to need an extremely small boring bar to do that. So this gives me a little more options here. It makes it a little easier to finagle this. All right, so without further ado, let's go ahead and rough this out. Let's go ahead and just do it with a quick rough again. So quick rough, and I have a single side. I'm actually going to do a partial, and I'm going to select that. Check. And of course, I am going to need a boring bar, which I find right here. So I'm going to start with a 3/16 diameter boring bar, and I'm going to try and see if that will work here. I know I can get it to work, so I'm going to go ahead and give that a go. My stock to leave, I'm going to leave this 0.05 because we're using a small boring bar now, so I'm not going to leave a lot of stock because I don't want deflection. So we're going to go to wear, or control. Let's see what my lead in shows me here. So we got our lead in, lead out. Okay, so I don't have anything left in here. Sometimes that carries over from when you've used a quick rough or just a rough before. Just want to make sure that wasn't in there, because if it was, it would try to finish way down here and it would crash. Okay, so use stock router boundary. That looks good. Or let's do, in this case, remaining stock, because we've already machined some away. Wow, that looks great, except for the fact that we're taking 100 thousandths on our rough. Way too deep of passes for that small, just because I overlooked changing this 0.1. So let's make that a 0.025. We'll take 25 thousandths with this and hit check. And let's see if we can get away with that. It looks like we can. All right, so that's pretty cool. So what I was worried about there was, if I just regen this, I was worried about this backside of this boring bar hitting the bottom here, but it doesn't. So we're in good shape there. Okay, so let's do a finish quick, a little quick finish, and get this bore out of our way. Quick finish. Okay, it's got that. All right, everything looks good there. It's only going to take what the step over doesn't matter, because it's only going to take what we have on there. So we're fine with that. Control still selected. Lead in, lead out. Those look, ooh, okay, that's a problem. So I'm going to run it with that. Let's just let you see what happens here. So it's all through the right. Okay, I have a feeling. Oh, yeah, okay. All right, so based on the settings there, I want to see what this would do. So you kind of see it. So basically what it did was, since it didn't ask us to select a contour, it assumed a roughing operation. But it assumed the wrong one. It assumed the outside roughing operation. So all I need to do is I just need to go in here and I need to select the right one. I could also chain it if I wanted to. But if I select the other one, and it's hard to tell the difference, you might have to try them both just to figure out which one it is. Then just go down through your operations again. And obviously I need to be off to the left if I'm boring. So I'm going to change this to the left. And I'm going to look at my lead in. Well, actually I'm going to hold off. I'm going to run this again. And I'll show you what's wrong with that as well. Okay, so you see how it comes out here? So that is a lead out problem. So we're going to go in there and go to our lead out. And you can see it's leading out that direction. So that means it starts, you think of where your tool is when it's cutting, or when it's finished the end of the cut, and the arrow or the skinny part points to where it's going to lead out to, and vice versa with the lead in. So we want this to lead 45 degrees down. So we're going to hit check, and that looks good. So let's see what that does. All right, that looks a little bit better. Okay, so if we go in there and we take a look, you can see that you end up with a little bit here, and it's not finishing the Z face. So this is the downside of using a quick finish or quick paths. You don't have as much control. So it doesn't want to finish that Z face. So that's a problem. So in order to get rid of that, I'm just gonna delete that. And I'm gonna hit yes. Make sure I only have that selected. And I'm gonna go in, I'm just gonna do a regular finish pass on this. So I'm going to select my contour, check. I'm going to pick that same boring bar. Of course, my spindle speed's 3,000. And so this is probably about 500. And feed rate 0.006 for a finish with that little boring bar. Max step, we're just going to take one. Max step over is only going to take off what we had left on there. So we only left 5,000 and 2,000. So we don't need to worry about that. Controls what we want. We're going to be off to the left. Our lead in, lead out. Lead in looks good. Lead out looks good. Plunge parameters. Those are both on. So this is what's causing the problem. It's not allowing us to plunge. We don't have that option in a quick finish or even in a quick rough. Obviously the rough is different, but the finish, it needs to plunge. So that's probably what our problem was, at least what I think our problem was. So you need to do a lathe finish here. And you can see now that looks great. Now everything there is lining up with the edges. So we have a finished bore. The other thing I want to point out is notice how I inspect everything after I do it, right? I'm checking to make sure all these lines line up. Oftentimes students and machinists don't check that stuff, and then they find out in the shop that their part's no good and have to come in, and it saves you a lot of time. That's why you have all this simulation. Make sure you scrutinize it. Make sure you scrutinize everything you do and everything looks like it lines up correctly. So anyway, we have all that finished. Bore's done, tap's done, profile's done. All we need to do is these grooves, and then we need to cut it off. So let's go ahead and groove this thing. I always usually do a chain. That's just me. So I like to do a chain, and I also like to separate them. I don't do multiple chains very often. Like, I tend to not do this. I usually tend to just do a single chain, and then I'll do another operation. I like to separate them so I can control them separately. So go ahead and do the chain check. And we're going to use this one here. And everything is good with the groove. Basically, we're leaving 5 thou on to finish, and it's going to come to finish. So all this stuff is set correctly. Compensation, we're of course going to put that in control as well. And it's not going to show perfect when it does that. So if I do a computer, you'll see here that there it looks good. If you have the control on it, of course it makes it different. I'm just going to leave that as is now so it looks good when we simulate it. We're going to run another one, hit check, check, all right, and just make sure we're on computer, everything's good there. All right, so they're grooved out. Let's go ahead and cut this off. So cut off, select my part boundary, select the back of my part, and of course I want to use this one, and I'm going to hit cut off parameters from stock, I want to add a chamfer on the back. I always chamfer my parts on the back, always. There's no reason not to. Go ahead and do the parameters. I'm just going to put a 0.015 chamfer on it, hit check. Going to put a clearance cut, and I'm going to make that 0 in the Z, hit check. Computer compensation, we're going to do control for that, and hit check. And let's take a look at what we got there. Whoops, I forgot to select everything. And let's go ahead and hit play as soon as this thing processes. Alright, let's save this before we do anything to make sure it doesn't crash on us. As always, I highly recommend you save as you go. Otherwise, things will go wrong and you have to start from scratch again. Especially before you simulate. Simulation is usually where you have those problems. Okay. Alright, so we have a little bit of an issue there. So let's go ahead and fix that. Let's see. Where are we getting that at? I'm going to bet that that is being caused by our control. Check. And let's try this again. Regeneration is really slow on this this thing. All right, let's see what that gives us. And there we go. So that looks good. As you can see, everything is visible. Obviously, we already know that that's off because of the control, the compensation, but everything is finished on there. And those lines you see in there, that kind of like faceted surface, that's just graphics. That's not anything to be concerned about. But anyway, that's all. That's all I have for this lesson. So if you have any questions, as always, you can see me in my office hours, or, of course, you can see me during class.